Let's move on to the next question of this paper, that is 19 number. The equation of a tangent to the hyperbola, equation is given, parallel to the line x minus y is equal to 2. Now, we have the slope of the required line, that is 1. We can find the equation of tangent for this hyperbola when the slope is known. That's a simple one. So, let's start this question. Tangent is given by y equals mx, m is 1. So, write here directly x plus minus square root of a square m square minus b square. Now, when you divide it by 20, it becomes x square by 5 minus y square by 4 equals 1. So, a square is 5 and b square is 4. So, write down 5 minus 4. So, the equations obtained are y equals plus minus 1. Let us see, x minus y, it is given in all. Then we have x minus y plus minus 1 equals 0. Yes, we can see correct answer is option number 2. I am sure this is clear, a simple question from coordinate geometry. Let's move on to the next question, that is question number 20. F, a function is given such that fx is cubic polynomial, we can see, then f2 is equal to, for the sake of simplicity, let's start like this. Say this is a, this is b and this is c. So, we have the polynomial like x cube plus ax square plus bx plus c. Now, find the derivative 1, derivative 2, derivative 3, so that you can put the values here and equate to get the final result. Let us begin with this question. We can write here fx is equal to x cube plus ax square plus bx plus c. Now, f dash 1 is required, correct? When you differentiate, it is 3x square. So, write here 3 plus 2a plus b, this is equal to a. Now, this is simplified as a plus b is equal to minus 3, equation number 1. This is clear. Go for the second derivative. Second derivative is required at x is equal to 2. Okay. So, 3x square was the first derivative. So, 6x, meaning it becomes 12 plus second derivative after 2ax, it becomes simply 2a. So, write down 2a, rest terms are 0, is equal to b. So, from here we have the result with us as 2a minus b is equal to minus 12. This is equation number 2, right. Third, f triple dash 3. When you go for the third derivative, it is simply 6. This is c. When you talk about equation 1 and 2, just add the 2. Adding, we see b is cancelled, 3a is equal to minus 15. So, just write down. Therefore, from 1 and 2, we get the value for a as minus 5. Put the value of a back as minus 5, you find b is equal to 2. C is already obtained. Now, we have the function with us fx is equal to x cube minus 5x square plus 2x plus 6. Now, what is being asked in this question? Simply the value of the function at x is equal to 2. So, write down here, therefore, f2 is equal to 8 minus 20 plus 4 plus 6. On simplifying, it becomes minus 2. Let us see whether it is available with us in the given options. Yes, minus 2 is there as option number 3. So, let us mark and mention the correct answer. I am sure this is clear. Let us move on to the next one, that is question number 21. If the system of equations, we have 3 equations given to us, has infinitely many solutions, we have to find the value for beta minus alpha. So, let us write down these equations as the matrix equations. Matrix equation, that means we are talking about 1 1 1, 1 2 3, 1 3 alpha. Then we have x y z is equal to 5, 9 and beta. Now, when you apply here R2 minus R1 and R3 minus R1, you can see the elements in first column become 0. So, R3 replaced with R3 minus R1 and R2 replaced with R2 minus R1. This gives us 1 1 1 0, 1, 2, 0. Then here we have 2 and alpha minus 1 multiplied with here x, y, z, and next we have here 5, 4, beta minus 5. This is clear? Now, when you go with this question, in the next step you are going to get the final one. Instead of applying R3 replaced with R3 minus R1, we can also apply R3 replaced with R3 minus R2, but it is not going to make any difference here. Next, R3 is replaced with R3 minus 2R2. On applying it, we get simplified form 1, 1, 1, 0, 1, 2, 0, 0, alpha minus 5, then x, y, z, and lastly we have 5, 4, beta minus 4 into 2 subtracted, that is beta minus 13. This is clear? Now we are talking about infinitely many solutions. When can you get infinitely many solutions? Here, when this term alpha minus 5 is 0 and simultaneously beta minus 13 is also 0. This is clear. So we have the value for alpha and beta for infinitely many solutions. For infinitely many solutions, the required condition is alpha must be 5 and simultaneously beta must be 13. Now let us see what is required in this question. Question is asking for beta minus alpha, that is 13 minus 5. So what is the correct answer here? 8. Yes, it is available here as option number 3. So let us mark and mention the correct answer. I am sure this question is clear. Let us move on to the next one, that is question number 22.